For this station, you will need a tape measure, a stopwatch, and a tennis ball. Run the tape measure from the height at which the ball will be dropped to the ground to measure the height of the stairwell. Have one person stand at the top with the tennis ball, and have the other partner stand at the bottom with a timer. Record the height of the stairwell, which you measured with the tape measure from where the ball will be dropped. Have one partner let go of the tennis ball while the other person presses go on the timer. Stop the timer when the ball reaches the ground and record the amount of time it took the ball to fall. Repeat for 3 trials.
So in this lab, we measured the height of the stairwell in feet. And so you have to convert that to meters. In this case, the height of the stairs was 37 feet, which becomes 11.25 meters. Then use the kinematic equation, distance equals initial velocity times time plus 1/2 acceleration times time squared. And then you find that the acceleration in this case is 13.11 meters per second squared, which was the acceleration due to gravity because gravity is the only force acting on the ball. Then you calculate the percent error using the accepted value of G, and in this case we got a 33.86% error. One source of error in this lab was the fact that it was difficult to tell exactly when the ball was being dropped and exactly when the ball hit the ground. The reaction time could have caused the timer to not be stopped exactly when the ball hit the ground. One improvement for this could be to have one person stand at the top of the stairs and one person stand at the bottom, have both people time it, and then take the average of the 2 times to use that to get a more accurate reading of the time it took to fall.
For this station, you will need a picket fence, a photo gate, and a ring stand. Set up the ring stand with the photo gate and connect it to Logger Pro. Once you hit collect data, drop the picket fence straight through the photo gate and be ready to catch it before it hits the ground. Find the slope of the velocity versus time graph in Logger Pro. This slope is the acceleration of the falling picket fence. Repeat this process for 2 more trials. For the Station 2 calculations, one must merely take the average of the 3 slopes of the velocity versus time graphs from the 3 trials. In this case, that average from the slopes is 9.7532 meters per second squared. Because it is a velocity versus time graph, the slope is going to be acceleration. In this case, the only force acting on the picket fence is gravity. Therefore, the acceleration given is going to be that of the acceleration due to gravity. Compared with the accepted acceleration due to gravity value of 9.80665 meters per second squared, we can calculate the percent error of this station. The percent error is less than 1% at 0.55% of error. This error may be attributed to the falling of the actual picket fence. If the person dropping the picket fence drops it at a slight angle, it will throw off the calculations as the photogate will not record it properly. To avoid this issue, one should practice dropping the picket fence through the photogate properly multiple times to ensure the most accurate results. You should also have one person watching the photogate as it falls to ensure that it is falling directly through the photogate.
For this station, you will need 2 photo gates, 2 ring stands, a tennis ball, a tube, and a meter stick. Place 1 ring stand on the table and 1 on the floor. Put a photo gate on each ring stand and position them so that the tube can fit in between. Measure and record the distance between the 2 photo gates so that you can know how far the ball has dropped. Once you hit collect data in Logger Pro, drop the tennis ball so that it passes through the first photo gate, the tube, and then the second photo gate. That will give you the starting and ending velocities of your ball being dropped.
Using the kinematic equation, velocity final squared equals velocity initial squared plus 2 times acceleration times the change in x, we can find the acceleration of our system. Because the only force acting upon the tennis ball is gravity, the acceleration we find should be equal to the acceleration due to gravity. With our final velocity of 3.288 meters per second squared, initial velocity of 0.471 meters per second squared, and displacement of 0.91 meters, we found that the acceleration of the tennis ball was 5.82 meters per second squared. Compared to the accepted value of 9.80665 per second squared, we had a percent error of 20.9%. This could have been due to the tennis ball hitting the photo gates. So make sure to use a trial in which you did not hit any photo gates.
After analyzing the resultant errors from each of the 3 stations for their accelerations due to gravity, one can determine which station best represents the accepted value for acceleration due to gravity. And the best method is the picket fence. The picket fence station showed the lowest percent error at less than 1%. There are the fewest outside factors acting on the picket fence as it is merely being dropped. If dropped precisely and carefully, it would fall and yield the best results for the accelerations due to gravity.